Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Soyan Lalo and I'll be guiding you through the chemistry course. In this particular lesson, we want to look at nitrogen and its compound. We will talk about nitrogen, we'll look at ammonia, we'll look at the ammonium salts, then the dinitrogen 1 oxide, then we'll look at nitrogen 2 oxide, nitrogen 4 oxide, tetraoxo nitrate 5 acid, tetraoxo nitrate 5s, that's the salts, and then we'll consider the nitrogen cycle in the wrap-up. Alright, let's get going. Nitrogen. What is nitrogen? Nitrogen is the most abundant gas in the Earth's atmosphere. It is the most abundant gas in the Earth's atmosphere. It occupies about 78% of the air of the Earth's atmosphere, that is the air. The air is made up of about 78% of nitrogen, and this is very beautiful because it has a lot of functions which it performs for us both in the air and around us. Nitrogen is a group 5 element. It possesses 5 outermost electrons and it has interesting behaviors. Some of the physical properties of nitrogen is that it is a colorless, odorless and tasteless gas. It is slightly lighter than air. It is slightly soluble in water, about 2% soluble in water at normal standard temperature and pressure, and it boils at minus 196 degrees and melts at minus 210 degrees Celsius. In the laboratory, when we want to produce nitrogen, we produce nitrogen through this particular reaction, a reaction between sodium nitrates, that's sodium dioxo nitrate 3. Sodium dioxo nitrate 3 is a salt. It's being reacted with the ammonium salts, that's ammonium chloride. When you react it, you have ammonium dioxo nitrate 3 and sodium chloride. Now, if you take this ammonium dioxo nitrate 3 and you allow it to decompose, it will decompose to form the nitrogen gas and water. It will decompose to form nitrogen gas and water. The equation is not balanced there. It is balanced now. It's decomposed to form the nitrogen gas and water. So, what are the chemical reactions in which nitrogen? Okay, how do we produce nitrogen industrially? For the industrial production of nitrogen, we go through what we know as the liquefaction of air. Liquefaction of air. Air is collected and liquefied. You cool air to temperatures as low as about 200 degrees, minus 200 degrees, and under pressure as about 200 atmosphere. That by that point in time, you will have extracted almost all the components of air, if not all. Carbon dioxide, that's carbon dioxide, is one of the components to get rid of earlier. Then you harvest your oxygen between about minus 163 degrees Celsius and 192 degrees Celsius. Then you can start collecting your nitrogen at minus 196 degrees Celsius. Okay, chemical reactions which nitrogen do engage in. It engages in direct reactions with very active electronegative elements, that is very active elements in the electrochemical series, such as magnesium, potassium, calcium and sodium. So when it reacts with them, it forms their nitrates. And these nitrates also can react with water to create the basis of these particular substances and ammonia. Ammonia is one of the most common substance produced using nitrogen. Also, nitrogen can react directly with non-metals. It can react directly with non-metals, and the most common of its reaction with non-metals is seen between nitrogen and oxygen to form the NO gas, the NO2 gas, and on certain occasions the N2O gas. Alright, let's quickly look at the different oxidation states of nitrogen before we go any further. Nitrogen exists between about 9 different oxidation states. It exists at -3 in ammonia. It exists as -2 in amine. It exists as -1 in the in this particular base, and it exists as 0 in nature since it can be found free in nature. It exists as -1 in dinitrogen 1 oxide. It exists as +1 in dinitrogen 1 oxide, +2 in nitrogen 2 oxide, +3 in nitrogen 3 oxide, that's trinitrogen 3 oxide, +4 in nitrogen 4 oxide, and +5 in trioxo nitrate 5 acid. Okay, so let's quickly take a look at some of the uses of nitrogen in our atmosphere. Nitrogen as an inert gas actually helps to prevent the overzealousness of oxygen when it comes to burning. So it helps us to regulate burning, regulate fires. It is an inert gas in air. Also, it is very, very important in the production of fertilizers. It is very, very important in the production of ammonia and other compounds as that ammonium salts, amines, different strains of proteins. It is also important when we're talking about chromatography. Nitrogen is used as a carrier gas in chromatography, and also nitrogen finds a very important use as a cooling agent. When you are able to liquefy air, it is a very, very good cooling. So, what are the uses of nitrogen? Nitrogen finds its uses in the production of fertilizers, in the production of ammonia, in the production of ammonium salts, in the production of many of our chemicals, amines, proteins. We also see nitrogen in being used as a carrier gas. It's being used as a carrier gas in chromatography. Because of the presence of nitrogen in the air, that is the inert gas in the air, we are not being burnt by wildfires. Of course, nitrogen suppresses the overzealousness of oxygen in supporting burning, in support of burning. And also, nitrogen also, when it is cooled, when it is liquefied, it serves as a very good cooling agent. Alright, we've talked about nitrogen in this particular lesson. In a very few seconds, in a short while, some questions will be displayed on your screen to test your understanding of what has been taught in this lesson so far. Please do well by answering them, and we'll get back to you in a few minutes. Welcome back. So earlier we talked about nitrogen. Now let's look at ammonia. Ammonia is a particular gas. It's a component. Is a gas made of nitrogen and hydrogen. It contains 1 part nitrogen and 3 parts nitrogen. It is produced in the laboratory by mixing together calcium hydroxide with ammonium chloride. Well, when we react our calcium hydroxide with ammonium chloride, it will give us calcium chloride, water, and to liberate ammonia. Alright, what are some of the properties? When we look at the physical properties of ammonia, we'll find that it is a colorless but choky. It has a choking smell. It's a colorless gas with a choking smell. It's poisonous in large quantity. When it is consumed in large quantity, it is poisonous. It is poisonous to the respiratory tract. Of course, it is an alkaline gas. Yes, it's an alkaline. It behaves like a base. It is about 1.7 times denser than air, and it has a melting temperature of about 34.4 degrees Celsius, and a boiling point temperature of minus 77.7 degrees Celsius. A boiling point melting point temperature of about minus 34.4 degrees Celsius, and a boiling point temperature of minus 77.7 degrees Celsius. It is very, very soluble in water. Very, very soluble in water. It can dissolve in water of about. It can dissolve by about 2,000 dm cube of. It can dissolve about 2,000 dm cube of ammonia in just 100 dm cube of water. That's how much it can dissolve in water. Alright, let's take a look at the chemical properties of ammonia. Some of the chemical properties of ammonia is that it reacts with oxygen to produce the nitrogen gas and water, of course. It is a very good reducing agent because of its basic properties. So it behaves like a base, it reacts with acids, it reacts with trioxocarbonates and other base behaviors. And also, it is a precipitating agent. since it will react with certain agents to form ammonium salts, most of which are not soluble in water. So it also decomposes thermally if you heat it to a temperature of about 500 degrees Celsius at standard temperature, at standard conditions, that is standard body and pressure. It would decompose. It will decompose to form the nitrogen and the hydrogen atoms. Okay, how is ammonium being produced industrially? Ammonia rather. How is it being produced industrially? Industrially, for the production of ammonia, we go through what we call the Haber process. The Haber process. In the Haber process, we have a particular apparatus, a very big apparatus, where we have nitrogen will be introduced into the system through a vertical vent. Hydrogen will also be introduced into the system through another vent. Now, the hydrogen will be pumped in 3 times as much as nitrogen that is being pumped in, and inside the system there is heat of about up to about 400 degrees Celsius, which is being sustained in the system, and we have fine iron, finely filed iron arranged also there. The iron acts as catalyst. The pressure and temperature also work hand in hand to do in the production of the ammonia gas. So the output of it will be the ammonia gas, which is usually being passed through water so as to liquefy it. It's also good to note that you cannot, if you want dry ammonia, you cannot purify ammonia, you cannot dry ammonia using concentrated H2SO4 like we usually like to do, because it is an alkaline substance, and we cannot use calcium hydroxide or calcium, you cannot use calcium hydroxide, because it would also react with it to produce an ammonium salt. Rather, we use quicklime, which is calcium oxide. So that is what we use in the cleaning, in the drying of ammonia gas. So let's talk about the test for ammonia. How do we test for ammonia, presence of ammonia? Ammonia gas turns turns red litmus blue. Because it is a basic gas, it turns red litmus blue. And when you allow ammonia to, if you take a droplet, pass ammonia through concentrated HCl, that is concentrated hydrochloric acid, it would burst into fumes. You'll see fumes coming out. That's to show you that that is the ammonia gas present. White fumes would be produced. Alright, what are the uses of the ammonia gas? Ammonia gas finds its uses in the softening of temporarily add water. We have added to temporarily add water to soften them. We also use them as solvents in laundry. We use them as solvents in laundry because they dissolve grease and certain other compounds as that. They dissolve polar compounds. Organic compounds, they dissolve them and they are able to take them out of the system. Also, they serve as refrigerants, though they have been taken out of use because they are toxic. They have taken out of use and been replaced by less toxic substances, but they can still serve as refrigerants in our system. And they are used as for making fertilizers. They are used in the making of fertilizers. They are also used in the preparation of certain chemical compounds. Certain chemical compounds such as ammonium salts, such as ammonium hydroxide, and other substances like that. So, ammonia gas finds its use in very many aspects of our lives. But let's go further by looking at the ammonium salts. Let's take a quick look at the ammonium salts. So for the formation of ammonium salts, they can be formed by reacting ammonia with the acids that needs to create that has the end component of the salts, that is the oxide form of the salts. Also, you can also produce them by reacting the ammonium hydroxide. You can also react ammonium hydroxide with the acid. Of course, if you react with the acid with it to have just a direct relationship and to produce this thing. But if you react the ammonium hydroxide with it will produce the salt with water. Alright, so when they are produced, all the ammonium salts are soluble in water. All of them, they are soluble in water, and apart from them being soluble in water, they are also not so stable. In fact, the most unstable one is ammonia, the one made from the carbonates. The ammonium trioxocarbonates. It is the most sorry, it's in the wrong way. It is the most unstable of them all. Very, very, very unstable. Any slight thing, it has changed form. So this particular compound, it's just when you heat it a little, it dissolves. It breaks down and forms nitrogen, carbon dioxide, water, and you just see that the entire ammonia, the entire salt is gone. It is not stable in nature. Also, all ammonium salts, when they are heated, they are non-stable. All ammonium salts, when heated, are not stable. In fact, ammonium chloride, it does sublime. When you heat it, it is the only one that does sublime. All the others simply just decompose. They decompose. But ammonium chloride, when you heat it, it sublimes. It sublimes and it forms ammonia and hydrochloric acid, hydrogen chloride gas. It forms ammonia and the hydrogen chloride gas. And when the condition is favorable, also it reconverts itself back to ammonium chloride. So it sublimes, that it changes from solid to gas and back to solid. Alright, so that's basically everything about the ammonium salts. Let's talk about the dinitrogen 1 oxide, aka the laughing gas. I'm still unable to fully comprehend how it makes people laugh. Maybe it is because of the uniqueness of its structure in terms of the smell, but it is known popularly to make people laugh. It just makes you laugh for no reason. I still don't understand. Anyways, this particular gas is produced in the laboratory by simply reacting your decomposing your sodium trioxonitrate 5. But to do this, to get sodium trioxonitrate 5, because it is not so stable, we have to first react potassium trioxonitrate 5 with sodium chloride, which is a stable form of sodium ammonium salt, and you will get potassium chloride and sodium trioxonitrate 5. Now the sodium trioxonitrate 5 will be allowed to be heated a little, and that will lead to the decomposition, which will form water and N2O, that is the nitrogen 1 oxide. Alright, so what are the physical properties of this particular gas? It is colorless. It has a faint, pleasant but sickly smell. It has a faint, pleasant but sickly smell. It has a sweetish taste. It is soluble in water, fairly soluble in water, cold water. It has a density that is about 1.5 times as heavy as that of air, and it is neutral to litmus paper. Alright, how about the chemical properties? It does not burn in air. So it itself does not burn, but it supports burning. It decomposes in red heats, and when it decomposes to form nitrogen and oxygen. That's when it decomposes. It decomposes to form nitrogen and oxygen. Now, apart from that, it reacts with non-metals such as sulfur, phosphorus, and it reacts with them to liberate the nitrogen. Also, it reacts with metals as a reducing agent to liberate the nitrogen as well. So, how do we test? How do we test for dinitrogen 1 oxide? Dinitrogen 1 oxide. To test for dinitrogen 1 oxide, if you have a burning flame, if you have the gas, just take a matchstick that is dying. If you throw it into the gas, it will rekindle. That is, it will spark off as though it wants to start burning afresh. So that's what it does. It rekindles dying glows and dying flames. And of course, there are only two substances that do that: oxygen and dinitrogen 1 oxide. So oxygen does this, but oxygen has an odorless, colorless smell. It has an odorless smell, while dinitrogen 1 oxide has a pleasant smell. Alright, let's quickly go to look at the nitrogen 2 oxide. Alright, let's quickly take a look at nitrogen 2 oxide. Nitrogen 2 oxide, of course, it is produced in the laboratory using this particular reaction. In this particular reaction, we have copper. Basically, just react any metal with your trioxo nitrate 5 acid. It would give you your nitrogen 2 acid as then give away as the escape gas. When you react the metal, it produces the salt of the nitrate and also liberates water and give away nitrogen 2 oxide gas. That is what will be the end product. Now, what are the physical properties of nitrogen 2 oxide? Nitrogen 2 oxide is a colorless but poisonous gas. It is colorless, but it is poisonous. It is insoluble in water. It is slightly denser than air, and it is neutral to litmus. So when you test it with litmus paper, it tells you nothing is wrong, but it is actually very poisonous. Very, very poisonous. What are the chemical properties? It reacts with oxygen to form nitrogen 4 oxide. That's one of the reasons why it is poisonous, because when it is exposed, when it is inside you, it seeks oxygen. It is oxygen seeking. It also can be decomposed. It can be decomposed at very high temperature. That's at red heat, about 600 degrees Celsius, to decompose to form nitrogen and oxygen. It reacts with metals to liberate nitrogen. It reacts with metals to liberate nitrogen. It is a very, very good reducing agent. Also, it has this reaction with metals. There's this with trioxosulfate salts, that it blends with them as though it's a part of them to form a complex salt, but it's decomposed. So it is a forward and backward reaction. It's a reversible reaction. When you mix it with them, it kind of forms a complex salt with them, and it also decomposes shortly afterwards. To test for the presence of a particular gas that is suspected to be this particular nitrogen 2 oxide, what you need to do is just expose it to air. Expose the colorless gas to air. On exposure to air, the colorless gas will turn to reddish brown. It will form reddish brown particles and to show you the presence of nitrogen 2 oxide. So, let's go on to look at nitrogen 4 oxide. The nitrogen 4 oxide is a very interesting particular gas. It is a dangerous gas, a very poisonous gas. In the laboratory, it is produced by decomposition of very high trioxo carbonate, very heavy trioxo nitrate 5 salts like lead trioxo carbonate 5 salts. Because the reason why we choose those kind of salts is because they are not so stable. So when you heat them to certain temperatures, they decompose, and when they decompose, they form it forms lead oxide, oxygen, and 4 atoms of the nitrogen 4 oxide. The nitrogen 4 oxide has physical properties such as it is reddish brown in color. It's a reddish brown gas. You see, when we expose nitrogen 2 oxide to air, that is what is formed. The nitrogen 2 oxide absorbs oxygen from the air to form the nitrogen 4 oxide, which is a reddish brown substance. It has an irritating smell, and it is poisonous. It is acidic, therefore it turns damp litmus paper red. Also, it liquefies at about 21 degrees Celsius. It liquefies at about 21 degrees Celsius to form a pale yellow liquid, and it is heavier than air. It is heavier than air. So when it is exposed to air, it tends to fall. So it is called a falling gas. Of course, let's look at the chemical properties of the gas. It is kind of unstable in some of its properties. It can come in its pale form when you have N2O4, and it can come in its reddish brown form when you have the nitrogen 4 oxide, and it can also decompose to form nitrogen 2 oxide and oxygen. All these reactions are reversible, so it can go either direction depending on what condition is favorable. It supports burning, but this gas itself does not burn. It supports burning. It is a very, very good reducing agent. It's a strong reducing agent. When it reacts with water, it produces the acid trioxo nitrate 5, and it also produces something that looks like an acid, which actually decomposes again to form the trioxo nitrate 5. So it produces a temporary acid, not so stable. And when it reacts, that is the nitrogen 4 oxide, when it reacts with alkali metals, that is soluble bases, when it reacts with alkaline, it forms their salts. That's the nitrate salts and the nitric salts, then water. These salts are very, very important in the making of fertilizers and compounds like that. Sometimes they are used even in the making of explosives. Alright, so that's it about nitrogen 4 oxide. Let's go to look at the trioxo nitrate 5 acid. The trioxo nitrate 5 acid, it is produced in the laboratory using one of the salts by displacement, using one of the salts in reaction with the tetraoxosulfate 6 acid. So we can have a potassium trioxonitrate 5 reacted with tetraoxosulfate 6 acid, and we'll have the acid produced and the sulfate salts produced. For industrial purposes, we do produce it by burning ammonia in air and allowing the products to go in. This air will be allowed to flow through the system, which has platinum rhodium as the catalyst at about 700 degrees Celsius. When it flows through this, it will purify it and to bring out just the nitrogen. Now the nitrogen and the air also would follow through. Now when the nitrogen and the air pass through, the two of them react together to form the NO2. Now this NO2 will also be allowed to flow forward and water will be poured, and also in the presence of air, oxygen is also further added and the acid will be produced. So that's how we produce it industrially. What are the physical properties of this particular acid? It is a fuming liquid. It's a fuming liquid. It is always like boiling every time, and it has a chalky smell. It is colorless and it turns to yellow when it is exposed for a while. And what happens? It turns to yellow because it is decomposing. The nitrogen 4 oxide in it is trying to escape. When it decomposes and nitrogen 4 oxide comes out, the nitrogen 4 oxide is also soluble in the substance, so it's kind of like dissolves into it again, and it forms this yellowish appearance. It decomposes to form nitrogen 4 oxide, like I earlier said. It has a boiling point of 86 degrees Celsius and a melting point of about minus 47 degrees Celsius. It is very miserable with water. You can mix it with water, and it is very, very, very corrosive. Now let's look at some of the chemical properties. As a chemical, it acts like an acid completely, which means it reacts with bases to form salts and water. It reacts with metals to liberate hydrogen and form salts. It reacts with trioxocarbonate to liberate carbon 4 oxide, form salt and water. Also, it displaces other acids which are lighter, of lower than it in the electrochemical series. It displaces other acids also from their own salts in a condition where it is capable to do so. It's a very good oxidizing agent, and it decomposes. It decomposes to form the materials which they use to produce it in the industry. Alright, what are the uses of the trioxonitrate 5 acid? Uses of trioxonitrate 5 acid. It is used as an oxidizing agent. It is used as a fuel in rockets. It is used as fuel in rockets. It is also used as a solvent for cleaning and purifying gold and platinum. It's mixed with hydrochloric acid at certain proportions for this particular task. It is used in making of fertilizers, in making of dyes, in making of medications, some particular drugs. It's also used in the making of explosives. It's used in making of explosives. Alright, then that's it about the trioxo nitrate 5 acid. Let's quickly look at the trioxo nitrate 5 salts, and we can go to the nitrogen cycle afterwards. The trioxo nitrate 5s, the salts, are produced by simply reacting the acid with either their base, the metals, or even their trioxocarbonates, depends on the material, the nature of the material, the metal in question. They are formed and they produce what you need. Now, all of them do decompose. All of them. The sodium and potassium, these two decompose to form a simpler salt of it and liberate oxygen. When it comes to the mercury, gold, and silver, they decompose to form the metal, oxygen, and nitrogen 4 oxide. While the ones that have substances like calcium and the rest of the other metals, they do decompose to form the oxide of the metal, oxygen, and liberate nitrogen 4 oxide. So basically, this is what happens when you decompose them, when you heat them to certain temperatures. Now, to test for the presence of trioxocarbonate 5, that is a particular trioxocarbonate 5 salt, what you need to do is what is called the brown ring test. The brown ring test. You put a liquid in a test tube and you put concentrated H2SO4 in droplets into it. As you pass the droplets into it, the reaction would occur and a brown ring would be formed in the middle of the solution. There will be 3 sets of layers, one at the base, one at the top, and in the middle of it all you have the brown ring. This is to show the presence of the nitrate, that is the trioxo nitrate 5 compound. Alright, let's quickly look at the nitrogen cycle and we can wrap it up. The nitrogen cycle simply talks about the connection of dots, how the nitrogen gas is being used up in nature, how it is being used up and how it is being replaced in nature. Nitrogen as an element, it can be found in different states. It can be found in the gas, in the air, it can be found in other compounds such as minerals, it can be found in some liquids. It is also very, very important to plants, just as important as it is to animals. So let's quickly take a look at what the cycle of nitrogen looks like. On your screen about now, you have a picture of what the nitrogen cycle looks like. You can see that the nitrogen cycle, we can see that it starts from the atmosphere and it goes into the earth via oxidation, and it is absorbed by plants to produce fruits or food. The food is being eaten by animals. The animals who eat the food actually give the food, either the herbivores eat it and die, and then the nitrogen that is stored in their body is being returned back to the earth, or the herbivore gets eaten by a carnivore. The carnivore eventually dies. All these things, apart from even dying, the excretes, urine contains a large volume of nitrogen. That's why when you urinate, it has been said that ammonia has the smell as though there is a urine, a thick quantity of urine in a particular location for a while. So if you look at it, it's a circle. Everything just connects. All the dots connect. So it is being replenished. It is being used up. It is being replenished. And that's why we call it the nitrogen cycle. It starts from a point, it goes around through different phases, and it comes back to where it starts from, which is the atmosphere. The atmosphere gets back its nitrogen from us animals as we respire, as we breathe, gets back some of the nitrogen. Also, the earth itself releases some of the nitrogen back to the atmosphere. All right. We've come to the end of this particular lesson. In this lesson, we considered nitrogen. We looked at ammonia, the ammonium salts, the nitrogen 1 oxide, also known as the laughing gas. We also considered nitrogen 2 oxide, a very poisonous gas. We looked at nitrogen 4 oxide, which actually is acidic in nature. We talked about the nitrogen trioxo nitrate 5 acid and the salts thereof, and we just briefly discussed the nitrogen cycle. Alright, in a few seconds some questions will be shown on your screen. Please answer them And if there is any part of this lesson which you have any difficulty with, you can go over the video another time for better clarification. Thank you.